force, concepts, and effects of forces. At the end of this lesson, you will know what force is, and you know the different types of forces that there is. And then we'll look at Newton's second law of motion, and we'll look at certain practical applications of force in real life. And finally, we'll conduct experiments to demonstrate the different types of forces that we have. Okay, so let's start with the basic question. What is force? So force is a push or a pull, as simple as that. The effect of that push or pull is that it can change the state of motion, or it can change the shape of an object. So take, for example, if you get home and you want to enter your room, you will have to open the door. To open the door, you need to apply a force, either by pushing the door inward or pulling it towards you. That pull or push is as a result of a force. So basically, that is a force for you. So a force is a push or a pull, and the effect of that force is that it can change the state of motion of an object. Another example is you have a ball, a soccer ball on the pitch. You can kick it towards the goalpost. To kick it, you need to apply a force, and the force will now cause the ball to move towards the goal. Another example again is you have an empty tin of milk. When you use a hammer to hit it, it's going to deform the tin of milk, the empty can. And the empty can is going to deform or change in shape. That's an effect of a force because you applied a force. So basically, that is force, and we'll look at some types shortly. Now, it's important to know that force is a vector quantity. That means that it has a magnitude and a direction. Whenever you apply a force, you apply it in a specific direction, and because of that, force is a vector quantity. The unit for force is newtons, and it's named after Sir Isaac Newton, who discovered it. As I already mentioned, force can cause a change in motion, or it can cause a change in shape. Okay, let's look at the types of forces. In this lesson, we'll talk about 4 types of forces. One is frictional force, the next one is gravitational force, the third is cohesive force, and then the fourth is adhesive force. So we begin with frictional force. So frictional force is the force that opposes motion. So if, once again, let's use our ball example. If you have a soccer ball and then you kick it towards your colleague, the ball is going to move and then eventually to slow down. So the question is, why does the ball slow down? Why doesn't it continue on without slowing down, endlessly traveling? It stops because of friction. And we're saying that the friction is a force that opposes the motion. So as the ball is moving towards you, it's going to slow down because there's an opposing force that will cause it to slow down. That force is what we refer to as friction. It's usually parallel to the surface in contact, and it depends on the roughness of the surface in contact. So the more rough the surface that the ball is traveling on, the higher the frictional force, and the higher the frictional force, the higher the rate at which the motion will be opposed. So basically, that is frictional force. It's a type of force. Frictional force can be beneficial. At the same time, it can be detrimental. Beneficial in the sense that when you are walking on the ground, frictional force is one of the forces that helps you not to slip. If there was no friction between the ground and your feet, then you are likely to slip. It's like walking on, let's say, tiles with water on it. So you have tiles and then you have water on the tiles. It's very slippery because the friction is very less. Compare that to walking on sand or the ground. You realize that it's more easier to walk on the ground because of the effect of friction. So in this case, friction is beneficial. Now, friction can also be detrimental in the sense that it can slow objects down. So when a car is moving, it may not be able to move as fast as it wants. For example, if a motor is riding on gravels or in sand, frictional force will oppose its motion and will not cause it to move as fast as it wants to do. So in this case, friction is acting detrimental here. So basically, that is about friction, which is a type of force we need to know about. The second type of force here is gravitational force, and gravitational force is the force of attraction between two objects with mass. So gravitational force is that force that causes human beings to be pulled or be anchored towards the surface of the earth. So without gravity, human beings cannot stay on the surface of the earth. Maybe we'll just move up and up and up. A practical example is when you throw anything up, it will come back down to you because there's a force that is attracting the thing towards the surface of the earth. So the object that you throw up is an object that has mass, and then the earth too is another object that has mass. So the force of attraction between these two masses is what we refer to as gravitational force. So it's the same force that keeps planets in orbit around the sun. So this gravitational force is always proportional to the product of the masses and inversely proportional to the square of the distance. That's a little bit deep, but just know about that. So basically, this is another type of force we need to know about, gravitational force. We'll be using the formula force equal to mass times gravity later in calculations. Let's look at the third and fourth types of forces that we have. We have coercive force and then adhesive force. Let's talk about coercive force first. So coercive force is the force of attraction between molecules of the same substances, and it usually causes them to stick together. So if you have seen mercury before, mercury has high coercive forces and it causes the molecules of mercury to stick towards each other. And it's this same cohesive forces that allows or causes water to form droplets. So water can be seen in droplets because of the cohesive forces between the molecules of water. So that is about cohesive forces. So the fourth one is adhesive forces. Adhesive forces is the force of attraction between different substances. And this is very important. Take, for example, the force of attraction between a glue and then, let's say, paper. You can stick two papers together and then they will stick strongly to each other because of cohesive forces between the paper and then the glue. And that is also a force. Sometimes you can apply super glue to any objects that you have in your house that gets broken, and they will stay together. They are staying together because there's a force of attraction pulling the objects together that is being supplied by the binding agents, which in this case is super glue. So that is also a force, which we are calling an adhesive force. Okay, so that's about the four types of forces that you need to know about. Now we move to certain concepts that we use when we are talking about force. I told you that force can cause motion. So if you have a ball, you can kick the ball and the ball is going to move through a certain distance. And once the ball begins to move, there are certain concepts that comes into play. One of them is distance, the second is speed. So if you kick the ball from one position to another, let's say from the center circle on a pitch towards the goal, we can ask how far did the ball travel? That is a distance. So distance is one of the concepts that we apply when we are talking about force. And distance can be measured in meters, can be measured in kilometers, or it can be measured in miles. So I can ask you, from your house to the school, what is the distance? You can say maybe 2 kilometers, or maybe you can say 10 kilometers. You can say, oh, maybe 500 meters or so. So that is a distance between your house and then the school. With another important concept in force is speed. So speed is basically the distance between 2 points and the time it takes to cover that distance. In simple terms, is how fast an object travels. That will be its speed. So for example, the distance from your house to the school is 2 kilometers. What time did it take you to cover that distance? So maybe it took you 30 minutes. Then your speed will be the distance 2 kilometers over 30 minutes. And in this case, 30 minutes has to be converted into hours. So basically, that's about distance, and it tells us how fast or how slow you move. So compare two examples. If you have two people, let's say they are siblings, one is coming with a bicycle and the other person is walking. So who will reach fast? Clearly, the one on the bicycle will move faster because that person will have a higher speed than the person who is walking. That is also because the time it will take the person walking will be higher than the time to take the person on a bicycle, because a bicycle is faster, it has more speed. So to calculate for speed, we have the formula distance divided by time. So let's look at an example here. If the distance is 150 meters and then the distance is 150 kilometers and the time is 3 hours, then your speed is your distance over your time, which is 150 over 3, which is 50 kilometers per hour. So distance is measured in kilometer per hour or meter per second or miles per hour. Any of them is correct. Now, it's important to note that distance and speed are scalar quantities. That is to mean that they do not have any direction. They don't have any direction. Now, let's move to the next two important concepts about motion. The first one is velocity. Now, velocity is almost the same thing as speed, just that it's in a particular direction. So, for example, the formula for velocity is displacement over time. Displacement is distance in a specific direction. So, for example, when you move from your house to the school, the distance is 2 kilometers. Okay, but what is the displacement? The displacement is 2 kilometers to the east. The fact that I added the direction, the east, to it now changes the name to displacement. So the difference between speed and velocity is that velocity is a vector, it has a direction, but then speed is a scalar and it has no direction. So the formula for velocity is displacement over time. So in this particular example, you traveled at 400 meters east for 60 seconds. So what will be your velocity? Your velocity will be 400 meters divided by 60 seconds. So your final answer will be 6.67 meters per second east. In most examples that we give, we make it simplistic so we don't worry about the direction a lot. But then, to be accurate, whenever you talk of velocity, you need to include the direction. And that's the main difference between velocity and speed. Now, the second important concept here is acceleration. Acceleration is the rate of change of velocity over time. So if you take how fast you are moving divided by your time, you get your acceleration. Usually you have a starting velocity and then an ending velocity. Your starting velocity is your initial velocity, which we represent by u, and then your final velocity is represented by v. So take for example, if you are riding a motorbike, you start from gear 1 and then you want to move to gear 2. Now at gear 1, you are moving at a specific velocity. Then at gear 2, you are moving at a different velocity. To calculate your acceleration, you take the velocity when you're at gear 1 from the velocity when you're at gear 2 divided by the time to gain your acceleration. There are times when you move from rest. Whenever you are at rest, there is zero velocity, or if you want, there is no speed. So if you start moving, you have gained velocity. So to calculate your acceleration, it will be your final velocity minus your initial velocity, which if you are at rest will be 0 divided by your time. So let's look at this particular example. In this example, we start from rest, which is the initial velocity is 0 meters per second. And then we have a final velocity of 20 meters per second. And then we move it at a time of 5 seconds. So to calculate for the acceleration, is 20 minus 0 divided by 5, which is equal to 4 meters per second squared. 4 meters per second squared. It's important to note that acceleration, the SI unit is meter per second squared. And then velocity, the SI unit is meter per second. So these are important concepts in motion. So we have velocity and we have acceleration. The formulas to calculate for each of them. So you should note this. So that brings us to the end of the concepts and motion. Now let's look at Newton's second law of motion. According to Newton's second law of motion, the acceleration with which you move is proportional to your net force and inversely proportional to your mass. If you do a change of subjects, you now end up with force is equal to, that's your net force is equal to your mass times acceleration. So this formula you need to keep at the back of your mind. Force is equal to mass times acceleration. It comes from Newton's second law, where the F is the force in newtons, the M is the mass in kilogram, and then the A is acceleration in meter per second, as we learned how to calculate just now. So we can be given a question. A car of mass 1,500 kilogram accelerates from 0 meter per second to 20 meter per second in 10 seconds. What is the net force? Now, to calculate for the net force in this question, we use the formula force is equal to mass times acceleration. Now, we have the mass, which is 1,500 kg, but we don't have the acceleration. To calculate the acceleration, we use the formula that we just learned about here. Acceleration is equal to final velocity minus initial velocity divided by time. In this question, the initial velocity, the u is 0. The final velocity, which is the v, is 20. And then the time is 10 seconds. So we find the calculation here. Acceleration is equal to 20 minus 0 divided by 10. When you put that in your calculator, you get 2.0 meter per second squared. Now, with that acceleration, you can easily calculate for the force or the net force. So the net force will be equal to 1,500 kilograms times 2 meter per second squared, which will be equal to 3,000 newtons. So that's about that. So Newton's second law helps us to calculate for net force when you are given the mass and the acceleration. Okay, now let's look at some real world application of forces. So in transportation, for a car to move, a force will need to be produced to move the car forward, and that force is generated from the engine. Is the engine that supplies the thrust for a force to be generated that causes the car to move. In sports and all forms of recreation, there is movement. For example, when you are playing soccer, the ball moves from one person to the other. It moves because of the application of force onto the ball. In construction, where we move heavy objects, we need to apply a force to cause the objects to move. And in our daily life, we apply force. For example, friction helps us to hold things. If you want to hold your pen, you need friction to allow you to hold it. Without that, it will slip through your finger. So there are a host of real world examples which you can tune your mind to. Then let's look at some practical investigation of the different types of forces that we mentioned. So frictional force, how do we demonstrate frictional force? We can conduct a very simple experiment. We have a wooden block, then we have a smooth surface, and then a rough surface, and then we push the wooden block across the two different surfaces, and then we measure how fast or the time it took for us to do that drag. You realize that on the smoother surface, it moves faster than on the rougher surface. And why is that? Is so because of a force called frictional force, which opposes motion. Then we look at the second one, gravity. We want to demonstrate gravitational force. We can have two masses of objects, one light and then one heavy, and then we basically drop them. You realize that the heavier one will drop faster than the lighter one, and that is because gravitational force increases proportionally with mass. There are other reasons why that will also happen, but that's not the topic here. Then let's look at cohesive force. We want to demonstrate cohesive force, and an experiment to do is to take a bowl, two beakers of water or two bowls of water, and for one of the setup, so let's say setup A, water alone, then setup B, you add salt to them. After adding salt, what you do is that you take a spoon and then you scoop the what do you call it, setup A, which contains only plain water, and then you release it from a height. You realize that they come in droplets, but you do the same for the one with the salt inside, and you realize that the droplet formation has been affected. Now, this is because salt water has lower cohesion, which affects the water droplet. So that's another or one way of demonstrating cohesion or cohesive forces. Then for adhesive forces, you can use capillary action to demonstrate that. Where you use a capillary tube, you insert it into water, and you realize that the water rises through the capillary tube because of the adhesive force between the water and then the capillary tube. So these are some practical experiments to demonstrate the different types of forces that we have discussed. Okay, so that brings us to the end of this lesson, and these are the important concepts at a glance. You should know what force is, you should know what distance is, and the units, and whether it's a vector or a scalar quantity. Okay, then you should know your formulas. You should know this formula for speed, that of velocity, acceleration, gravitational force, and then Newton's second law of motion. You realize that Newton's second law of motion and then the gravitational force is the same except for the G here. This Newton's law of motion is the same for this gravitational force, except that here the acceleration here is acceleration due to gravity. It's the effect of gravity that is causing the object to accelerate. And so the A becomes G here. Okay, so that is about that. These are some key definitions that you may need to know. Okay, so that brings us to the end of the topic force. If you have any questions, you can send them in the comments section. Bye.